Now this is of course not a numerical, but this will help you to write expressions for potential difference across a capacitor quickly. This will help you solving numericals. How to find potential difference across a capacitor quickly if two capacitors are connected in series. This is a capacitor C1, this is a capacitor C2 are connected together across a potential difference V. So the charge will flow like this. Now since these two are in series, both of them will have the same charge Q. So let us find out the effective capacitance. Since these two are in series, and we know in series the effective capacitance is found out. 1 by C effective is equal to 1 by C1 plus 1 by C2. From this we get C effective is equal to C1 C2 by C1 plus C2. Remember it as AB by A plus B. AB by A plus B, and this will be always less than A and always less than B. Now this is the effective capacitance. Now if these two are not connected like this, instead of C1 and C2, if you have a single capacitance, whose value is C1 C2 by C1 plus C2, that is same thing as this, and connected across the same voltage source V, then this single capacitance will draw the same charge Q as is drawn by the combination of C1 C2 in this manner. So this is your effective capacitance. So the charge is equal to Q is equal to C effective into V, because we know Q is equal to CV. So C effective is this, C1 C2 by C1 plus C2 into V. The same charge is in the capacitor C1, also in the capacitor C2, because they are in series. And we know Q is equal to CV. So from this, V is equal to Q over C. We will use this formula to find out the potential difference across this capacitor as well as this capacitor. Means across this capacitor, if you connect a voltmeter, what will be the reading? That is the potential difference across the capacitor C1 using this formula. So across this, let it be V1. So V1 will be charge flowing through this divided by its capacitance. Charge flowing is C1 C2 by C1 plus C2 into V. C1 C2 by C1 plus C2 into V. This is the charge flowing through this divided by its capacitance into 1 by C1. So C1 C1 cancels. So I am left with V1 is equal to C2 by C1 plus C2 into the total V. Now similarly, so what is the conclusion? What is the potential difference across this? Now the second capacitance divided by first plus second into the total voltage. Similarly, if you connect a voltmeter across here to find the potential difference across the capacitor C2, let it be V2. Similarly, the potential difference across a C2, let it be V2, and that will be the charge flowing through this divided by its capacitance. The same charge is flowing, C1 C2 by C1 plus C2 into V divided by its capacitance. So C2 cancels. So I am left with C1 over C1 plus C2 into the total voltage. Now, and if you add the V1 and V2, you will find, if you add this V1 and this V2 which we just calculated, you will find this plus this will be this total voltage V. So the conclusion is, if there are two capacitors connected in series, C1 C2 across a voltage source V, then across this the potential difference will be the second one divided by total C1 plus C2 into the total voltage, and across this the V2 will be the first one divided by total into the total voltage. You should remember this and remember this to do numericals quickly. Now, in both the cases, the denominator is same. This V is same. So V1 will be, so whether V1 will be more or V2 will be more. So it depends on the value of C2 and C1. Means if C2 is greater than C1, if this is greater than this, then V1 will be greater than V2.